that I'll be using openssl with the algorithm called AES provided by openssl. Okay, so first I have a file called message.txt. It's ready. Okay, so you can see the content. This is the secret message. Okay, now let's start encrypting it. First, we specify the tool, it's openssl, and then the command within encrypt, and then specify the algorithm, which is AES 2.6 CBC. And after that, I'll be using a function, which is a public key derivation function, which is public key derivation function to let's start the dash before it to implement and iterate it 1,000 times because this is a function that strengthens the key that generated to encrypt the password, to encrypt the message. Okay, so after that, let's specify the input, which is the message that we want to encrypt, and then specify the output, which is a new file called it's called the encrypted message. Yeah, encrypted.txt. Okay, so now ask to enter the password and confirm it, and that's done. Now the message is completely encrypted in the encrypted file. Let's see it. Okay, as you can see, the encrypted message. Okay, so now in the decrypt process, let's redo the process, but with a little bit different. Still the algorithm and the function still iterate 1,000 times, but this time let's put in the encrypt to the file, so that we wanted to decrypt from this file, and put the output would be decrypted.txt. Okay, and the only difference here is we want to add a -d at the end to specify the application to decrypt this not encrypted. Okay. So I've had to enter the password that I use for the encryption, and that's done. Now let's view the decrypted message. Okay, so next up, let's move on to the demonstration of the asymmetric encryption, which in this case I'll be using RSA. So let's specify the tools and the command. Let's first generate a private key and call it and specify the length of it as 2028 bits. Okay, so it successfully generated a private key. Let's view the information of it. RSA, put input, and put the as text with no output file. Okay, so here are the information that we used to create the private key. So here's from all this information of the private key, let's extract a private key. So SSL, RSA, put the private key in, and specify the output as public key. Put our private key to store in this file, and make sure that we are with the pop out, so no private key duplicate. Okay, so we've just routed the private key. Let's fill both of them. Here's the public key, and here's the private key. So, yeah, normally we would not like for people to see our private key, but okay, so let's continue. Now we have the two keys, the pair of keys. We can move on to decrypting and encrypting. So let's encrypt first. So as normal, let's now RSA keys so that we can interact with the keys. Let's input this time. We'll put in our message. .txt. This is the same file that we used in the first demonstration, and put it out as an encrypted file. .txt. And this time we would like to work with the private key, with the public key. So we've specified in and in key. So now we'll specify the public key. And put the mark so that the computer knows that we want to encrypt this message. I'm sorry. Oh, I misspelled in key. Okay, so the message has been encrypted. Let's view the encrypted message. Here's the encrypted. It's pretty long, so okay. So now let's decrypt it using the same, pretty much the same command that we would like to specify decrypt instead of encrypt here. And for the input part, we'd like to input the encrypted message here and specify the output as decrypted. txt and put in the private key using the E key mark. Okay, so now it has successfully been decrypted. Let's save it. Okay, as you can see, here's our message. Today I chose to use the exclusive oral encryption method, and this is a very simple method. Here I have created a diagram to demonstrate how it works. So here I've created a function. Here you can see which text a text and the key in order to encrypt or decrypt the message. So here I encode all the text into bytes with UTF-8, and here is the function that I created to make sure the key has the similar length as the message, so that they can be exclusive or the corresponding elements. So after making sure and duplicate the keys exclusive or in every element in the two bytes here, and after doing the algorithm, I decode the result back into text again. So here I can show for you. Let me comment this. Here I got the encrypted message. Here I put it in the plain text message and the key into the function, and I saved it into the encrypted message variable. Let's print it out. Okay, so here you can see the encrypted message. I can barely read what it is because it was encoded using UTF-8, and now we will decrypt the message. I would save it into the decrypt message and print it out using the same function, but this time I put in the encrypted message with the key. So I'm exclusive ORing all the encrypted message once again, so that it turns back into the original message. So here's the code that I've written to demonstrate the RSA encrypting systems. So I have a few methods. Here, RSA to work, I need to generate two keys, which one is the public key and one is the private key. And here, first I would have to assign two numbers, which is P and Q, for number. The implementation is done based on the steps specified in the slides in week 3, and I followed the step to implement these functions. So first we need to got two number P and Qs, and then generate the two keys, which is E and D. I have a function to find E, which is to get a random number that specified in this condition, that it must be lower than the phi here, which I called phi in my code. You can see here. So it must be lower, and there's no number between E and the phi that has a greater divisor than 1. So after finding E, I have to find D, which is a little bit more complicated. So first I need to find the mod inverse of E and the phi. So I have the two functions to do that here, which use the extended greatest common divisor. So here is the function, and this is the algorithm that was provided in the references. So here is the algorithm specified, so I implemented in the code. So after running it, I got all I have to do is to return the D, which is the modulus of X, the coefficient X, and the parameter M. So after we got the two public and private keys, all you have to do is to encrypt and decrypt the message. So here are the functions. I use encode the message into numbers, and then encoded it using the private and the public keys, which the power and then get the modulus. So with that algorithm here, I generated a key using the P being 17 and Q being 19. So let's print out the key. Here you can see the key. So let's encrypt a message. So here I have a message called hello, and this will be encrypted as a list of number. So I encrypted it. Let's bring it out. Here's the list of encrypted number, and after that I decrypted it using the decrypt function and the private key and the two keys again. Here we have an extra private key that only I know to decrypt the message. So this one. Here you can see the decrypted message.